we've spoken about relative humidity and reaching saturation. Now let's talk a little bit about clouds and how clouds form in the atmosphere. Clouds and eventually rain, because rain is what's important to bring water to the surface for drinking water and also for agriculture. So basically we have a process called convection where the sun heats the surface. It heats the surface, causes the air to warm, but also causes evaporation of water into the atmosphere. We said that moist air is lighter than the dry air, but also warm air is lighter. So when we have both warm, moist air, this rises up like a balloon, like a parcel of air. It cools as it goes up, and eventually it'll cool to the dew point temperature, and we'll start to see the droplets condensing, and that's what we call clouds in the atmosphere. Now, the cooling of the air occurs at a fixed rate, what we call the dry adiabatic lapse rate, or the dry adiabatic rate, which is around about 10 degrees cooling for every kilometer we go up, and 10 degrees warming for every kilometer we go down. So if we take a parcel of air which is 30 degrees at the surface and it rises up by 1 kilometer, it'll be 20 degrees. We take it up another kilometer, it'll be 10 degrees. Another kilometer, it'll be 0. So as it goes up, it also expands because the pressure is getting lower, so the balloon actually gets bigger, but it actually gets cooler, the air, and eventually it'll pass the 100% relative humidity, or the dew point temperature, and we'll start to see a cloud forming. Again, the opposite is also true. If we have air coming down from a mountain and descending towards the sea level, we'll also have a warming of that air by about 10 degrees every kilometer. So the air rises because of these thermals which are produced. Both we have warm air, but we also have moist air, which are both contributing to the lightness or the lower density of the air. This air will rise and start to expand, and eventually we get to a level which we call the condensation level, where we start to see condensation. And that's what will define the base of the cloud. The air will keep on moving up, and as it goes up, because the temperatures are lower as we go higher, we'll have more and more condensation, more droplets forming, and the cloud will start to develop. But we can only see the cloud after we start to see condensation. So we don't see what happens below the condensation level. And often this is what causes the condensation level to actually have a line across the sky. We'll see a picture in a minute. So we start again with unsaturated air, below relative humidity of 100% at the surface. The parcel will rise up, expand and cool, and at some altitude it's going to get to the temperature where the vapor is going to start condensing, give us droplets, and we'll actually see the cloud. So here you can see some images of clouds taken around the world, and you can see this line which we've added showing the lifting condensation level, LCL, which will be slightly different in different places. If we over a cooler area or a warm area, there may be at different altitudes, but generally on a specific day, the clouds forming in one location will all start at the same altitude to condense and to form a cloud. And here you can also see, you may have noticed that when you look, say, at a field of clouds in the distance, many of them have a fairly straight line along the base. You can actually draw a line here along the base of the clouds, and also these ones over the sea. And that line represents the altitude where the temperature has reached the dew point temperature, or where we've reached 100% relative humidity, and now the vapor which is rising from the surface up is being condensed into droplets and forming the clouds.